So today we'll see how the Kepler's laws are present. Now we can see here how why the Kepler is very important, because he is the one who has said that the earth is revolving around the sun in an elliptical orbit and not in the circular orbit. He was the first one to say, and it was all taken in 18th century itself. So he has stated three laws, and we'll call those laws as Kepler's first law, second law, and third law. And if you see the Kepler's first law, we call it as a law of orbits. Now, according to this law, the earth revolves around the sun in an elliptical orbit and not in the circular orbit. We know that ellipse has two focal points, and in one focal point the sun is present. Assume that the sun is present at one focal point. So the distance from sun and earth is not always the same in the complete orbit. So sometimes the earth moves very close to the sun and sometimes it moves very far from the sun, as the orbit is an elliptical and the sun is at one focal point. So like this, the first law states that every planet moves around the sun in an elliptical orbit with sun at one focus of the ellipse. The orbit in an ellipse is not a perfect circle. The sun is located at one of the two foci. And the second law, if we see, now if we draw a line from center of the sun to the center of the earth, and if we is after a certain interval of time, if you see, if we calculate that time interval to be delta t, now within delta t, how much area the sun sweeps from the center of the sun, the same area will be swept again in delta t. In any delta t, if we observe, the area swept by the earth is always the same. So we can say that a line joining the planet and sun sweeps equal areas in equal intervals of time. So if the time period is fixed, a portion of the time, if we take, let us call that time as delta t. Within delta t, how much area is swept by the earth, the same area will be swept again in another delta t. If we take another delta t, again the same area will be swept. Whether the earth is closer or far from the sun, it doesn't matter, but the area swept will be always the same. So this is the second law of the Kepler. So the earth sweeps equal areas in equal intervals of time. And we have another law which will decide what should be the time period of the earth to revolve around the sun, depending upon the distance from center of the earth to the center of the sun. That so as it is an elliptical orbit, we can say that it is a semi-major axis. So the third law states that the square of planet's orbital period is proportional to the cube of semi-major axis of the orbit. So time period means it is the time which it takes to revolve, to complete one revolution, t square. And A is the major semi-major axis. So we know that the semi-major axis is calculated by connecting the entire major axis from one end to the other end, and from the center to earth one end, if we take whatever value we have, that we call it as a semi-major axis. And if we assume the orbit to be a circular orbit, then t square is proportional to r cube if it is a circular orbit. Even the same law will be applicable even for the circular orbit also, where t square is proportional to r cube. So like this, we have the Kepler's three laws, and these three laws play very important role in launching the satellites. So, in order to calculate its time period or in order to calculate its eccentricity, area or location of the satellite, so all these parameters can be easily known by using this planetary motions.